don't know me, my name is Anna Bradley, and my experiment was on the decrease in weight of 5 different eggshells soaked in 5 different types of drinks for a week. My experimental question for this experiment was what type of drink out of Coca-Cola, iced tea, water, vitamin water, and Diet Coca-Cola will cause the most decay on tooth enamel when an eggshell, acting as a tooth, is weighed before and after soaking in the drink for 7 days. My independent variable was the type of drink that I was using, and my dependent variable was the amount of tooth decay in grams. My hypothesis stated that the eggshell soaked in Coca-Cola would cause the highest decrease in weight because Coca-Cola contains the highest amount of sugar out of the 5 drinks. I'll explain the role of sugar during tooth decay later in my conclusion. These are the materials that I used in my experiment. I used Diet Coke, Coca-Cola, unsweetened iced tea, water, vitamin water, a 500 milliliter graduated cylinder, 5 eggshells, a scale, tongs, and 5 cups. These are the steps I completed during my experiment. So first, I started with an eggshell that I cracked a hole in and drained the egg out of. Then I labeled a cup with the drink that I was going to be using. So for example, Coca-Cola. Then I measured 200 milliliters of Coca-Cola, and then I weighed the eggshell and recorded the starting weight of the eggshell. Then I poured the 200 milliliters of Coca-Cola into the labeled cup, and then I left the eggshell in the cup to soak for 7 days. I repeated these steps with all of the other 4 drinks, and then at the end of the week, I took the weight of all of the eggshells to record the finishing weight. So this is my data table, and as you can see, Diet Coca-Cola caused the highest decrease in weight, then it was iced tea, then it was Coca-Cola. Vitamin water and water did not cause any decrease in weight. My graph makes this easier to see. So these are what the eggshells looked like after they soaked for 7 days. So these first 3 eggshells were Coca-Cola, Diet Coke, and unsweetened iced tea. They all contain caramel coloring, which is why they turned the color that they did. This eggshell was soaked in vitamin water for the week, and the color of the vitamin water was like purple, which is why it turned gray. And the last eggshell was soaked in water, which is why and water does not contain any food dyes, so that is why there was no difference in color for that one. And not only was there a change in color, but for some of them, they were more sensitive. So like, for example, as you can see, Diet Coca-Cola is like really cracked, which actually happened while I was taking it out of the cup, and I'm always very careful with them, and it cracks so easily, which I will also explain why they were so sensitive later. So Diet Coca-Cola caused the most tooth decay because of the mixtures of the different acids in the drink. This data did not support my hypothesis because my hypothesis said that the high amount of sugar is what causes the most decay, when actually acids are the major cause of decay. In conclusion, the more acids and sugars that are in the drink, the higher a decrease in weight that there's going to be. So for example, Coca-Cola contains a high amount of sugar, but it does not contain a high amount of acids. So because of that, there was a decrease in weight of the eggshell soaked in Coca-Cola, but Coca-Cola did not cause the highest decrease in weight out of all of the eggshells. Another example would be water. The eggshell soaked in water does not contain any acids nor any sugars, which is why there was no decrease in weight of that eggshell. I was able to use eggshells to simulate teeth because eggshells and teeth are both made up of a hard substance that are made up of mostly calcium, and their similar ingredient is calcium carbonate. So as I was saying before, sugar is damaging on your teeth, and this is because bacteria on your teeth uses sugar to create its own acids, and then it creates plaque out of the acids, and then it uses the plaque to stick to your teeth, making it harder for it to be washed away. Acids are even more damaging than sugars are on your teeth, and this is because when acids that are not created by bacteria in your teeth, when they're exposed to your teeth, it causes your teeth to become thinner, and it causes different appearance and sensitivity, which is why the eggshell soaked in Coca-Cola was so sensitive, because of those acids. So what exactly are acids? Acids are a chemical substance that contains hydrogen ions. The stronger the acid, the more hydrogen ions that are going to be released. These were my references that I used during my experiment. I'd like to thank my parents, Marianne, my family, Emily Talco, Maggie Vaughn, Gabby Delgado, Davion Glover, Amna Arine, Sabrina Noble, Kirby Bradley, my classmates, and mostly Miss Min for all the help and support throughout my project. Any questions?
We'll take questions from the audience first, if there are any.
Yes.
So would it have, you think, almost the exact same effect on your teeth, those liquids, or is there a difference between, dramatic difference between your teeth and the eggshells?
So this depends because so your body's usually is able to fight off some acid erosion, but because the eggshells can't do that and they're being constantly soaked in the drink, that's why they got so damaged, because it was a constant thing. Yes.
Like what kind of acids were the dipropyl, like what are the specific ones, or was it just
Yeah. So one of them was citric acid, which I found citric acid is damaging to your teeth, and there was no citric acid in Coca-Cola. And there was also citric acid in the iced tea, and the iced tea and the Coca-Cola were the two, even though iced tea doesn't contain any sugar, iced tea and Coca-Cola both contain citric acid, and they were the two most decayed eggshells.
I think it's my turn. Okay. If you'd like to go back to your slide with the pictures of the eggshells, jog your memory. Okay, so this question is about your experimental design. So when you soaked these in different liquids, you say you soaked them in over 7 days, right? What was really important for you to keep it constant so that you have a fair test?
So I had to make sure that I kept constant the amount of days, because if I had soaked it for longer, there could have been more of a weight decrease. But I also had to keep the amount of liquid in the cup constant throughout the experiment, because my experiment was near the window, so obviously it was going to evaporate a little bit. So I was every once in a while changing it out to make sure that there was 200 milliliters of each, because there's a certain amount of ingredients in 200 milliliters, and I wanted to keep the 200 milliliters constant.
Good. This is another question about experimental design. So you had all these different liquids, right? And we know that since there are different types of liquids in drinks, the concentrations are different for probably all of them except for water. Does that make sense so far?
Yeah.
Okay. So if I'm going to ask you to think on your feet, and so it's okay if you don't know how to answer the question, but I think you can. My next question is, if you think the concentration of the sugars or the acids played a role, okay, if you think that, what kind of setup would you have that's a little different from this time if you were to do it again? If you thought the concentration would matter.
So if I thought that, I would probably take another drink that does not contain a high amount of acids and sugars, because if I thought that it was acids and sugars, I would want to use a drink that contains acids and sugars, and a drink that does not contain acids and sugars, so that I can prove my point.
My next question is about your science contents. If you want to go back to your data table or graph, that's okay. I know you mentioned this, but can you just tell us one more time why you used the eggshells to represent teeth?
So eggshells and teeth are both like a hard substance that's made up of mostly calcium. So they both share a similar ingredient of calcium carbonate. So that is why I was able to simulate them. And when they were being soaked in the drinks, the calcium is actually being taken from the eggshell and it's dissolving into the drink. So both of that, and both teeth and eggshells, the calcium is being taken from the egg into the liquid.
Okay, and you said that the acids have a stronger effect than the sugars
Yes.
in the drinks. All right, so are you saying that the acids and calcium carbonate have a chemical reaction together?
I didn't research that fully, but I think that yes, that's true because since your teeth are made of calcium carbonate, and the reaction between the calcium carbonate and the acids causes your teeth to become like thinner, and there's many side effects of acid erosion. So I would say yes.
Mhm. And if you remember the color changes in your eggshells, right? What is a color change an evidence of in
It's-
chemistry?
It's basically evidence of the food dyes in the eggs because all of the eggs that change color turn basically almost the exact color of their drink because of the food dyes in the drink, and of course water didn't change because there were no food dyes. So I think that just shows the food dyes changing it.
You don't think it's a result of chemical reaction?
I think that it could be, but I didn't fully research into that, but I think that's a possibility, yes.
Okay, so my last question has to do with the graph. All right, so you used Coca-Cola, but you found out the Diet Coca-Cola had a greater effect in your weight of your decay. What if you had used another drink, or even made a sugar solution that was high, very high, much higher in concentration of acid than Diet Coca-Cola? Where would you find that bar, or where would you expect the result to be on your graph?
I would definitely expect the result to be higher than Diet Coca-Cola, obviously. Diet Coca-Cola contains more acids than iced tea, but I feel that it would probably be even above the graph maybe, depending on how strong the acids are.
So the decrease in weight would be greater?
Yes.
Thank you, Anna.